Hey everyone, welcome to Cloud Masters. We're here today to talk about the unit economics behind large language models in production. I am joined by my co-host Sam Clark and also another doer, Sasha Hare. He's an AI and ML expert at DoiT International. And we have two additional guests, not from DoiT, Gad and Gabrielle from TensorOps. Maybe God, we'll start with you. Introduce yourself and what does TensorOps do? It's especially relevant given what we're talking about, and then we could jump right into the topic.
Thanks, Matan. Worth mentioning that I worked at DoiT before, and I set up my own company 2 years ago. We started off as a consulting company doing machine learning and AI, mostly focusing on helping companies adopt AI, and we were kind of like swept by the recent wave of artificial intelligence with generative AI and LLMs and OpenAI and all the madness that's going on around it.
Yeah, I do a lot of machine learning and solution architecture at TensorOps. Hopefully I've been working a lot with LLMs, so I hope I can help answer some questions.
Great. So the topic, again, it's LLMs and the costs, measuring the cost of them, the unit economics of LLMs in production. Being able to break down the costs associated with LLM applications. Why don't we just start from the beginning and just give a brief overview of LLMs, large language models, and just how you see their growing importance in maybe in general, but also across maybe specific industries you can talk about. And Sasha also is open for everyone here.
So have you ever used ChatGPT? Are you one of the 5 billion people who tried it?
5 billion? Yeah. I mean,
So
I use it all the time to summarize. When I write blog posts, I dump the whole post. I'm like, can you give me an idea of how I can write a conclusion,
yeah.
or to learn about things?
So to people who don't know what's LLM, so LLM is basically large language models. It's the technology or the models that are behind services like OpenAI, ChatGPT, and Anthropic, and Bedrock, and Bard from Google. So there is a whole set of products that was built on top of that technology. And yeah, we're seeing companies adopting that, people using it, people are writing blog posts about it. Matan, you're doing marketing. We think that marketing is one of the most common use cases that we see people using LLMs for.
I wanted to say also, it's quite commonly used for everything about knowledge. So if you have a lot of internal documentation at your company, you can use it. You put it behind your large language model and you can ask questions based on your internal company documentation. That's a very common use case as well.
I wanted to kick off, I guess, the main topic by maybe setting the stage about why it's so important to understand the costs associated with LLMs, because now you see lots of companies that are introducing new features that leverage, that are Gen AI features that introduce LLMs into their product. And so maybe you can walk us through an example or an actual customer without naming the customer. I think you shared a couple weeks ago, you shared a situation where a customer was building a POC, everything looked good. They were using LLMs, and then once they got into production, they had to pump the brakes on this and kind of reevaluate things.
Yeah, I think you see that LLMs are incredibly powerful tools, right? Like you can do quite amazing stuff with it. The level of knowledge that they have and generation, sometimes even the creators of LLMs are amazed by what they can do. So it's like, okay, humankind discovered that they can send a rocket to the space and get it back. But does it mean that you're gonna take that rocket to your grocery store every day just because you can? And of course, the unit economics of this doesn't work. You're still better off walking or driving there. And I think that this is a little bit about what's happening with LLMs. We found out that there is this incredibly intelligent pieces of software that can do stuff that is way more complicated than what we were able to imagine 2 years ago. But then when you're trying to get it to production, is it worth it? Like, is the cost of the infrastructure justifying using that rocket that can go into space and go back? Or should you use more traditional methods? Or maybe there is never going to be like a justification for what you're trying to do because nobody is willing to pay for that sort of automation.
Can you like if you're building a POC or if something's in dev, can you fully estimate what the cost would be in production once you introduce more usage, maybe different use cases, requirements that you didn't consider? Like, I guess I'm wondering, we're focusing specific on production, so something about it being in production makes costs go out of control, um, and so I was wondering maybe you could share a little bit about that, just to underscore the importance of like why we're even talking about this right now.
Yeah, I think Gabriel could basically say, we can go back and ask, how do you actually pay for LLMs, right? Like when a company is using LLMs, how do you pay for LLMs? So Gabriel, want to maybe take that?
Yeah, so depending on your use case, you're going to end up having different ways to pay. So there's pay by token, where you kind of have someone hosting your models, so you can host them yourself. So the ways in which this cost can come are very different, but essentially there's always the same thing where they're going to be big costs that are going to come to you're going to get a cloud bill somehow. And you need to evaluate if this cloud bill is worth your use case, and if there's any business application at all before you even start.
Yeah, I think it's worth mentioning that essentially there is two ways to pay for LLMs. One of them is you're paying by token, and a token is approximately a word, right? Like, let's not get into the nitty details of like what it is, but you're sending data in the form of words or symbols, and the cloud vendors are gonna charge you. And when I'm saying cloud vendors, I actually mean OpenAI, because we see them as a cloud vendor as well as Anthropic and Cohere. So they're gonna charge you by the amount of data that you're sending in, but also from the amount of data that they're getting back to you. So if you're asking like a prompt, you're sending one or two words and it returns a whole story, you're actually gonna pay more for the story that comes back than what you sent. So you're paying basically for the traffic coming in and out of these services that are wrapping the models. Another way to do it is to host your own model. So you can actually find LLMs online, open source models, and host them on your premises with your own GPUs. Or maybe you get one from Amazon, maybe you get one from Google Cloud, a machine that has a GPU, and you're hosting, and then you're paying for the infrastructure and not for the model itself. And then you can basically, get as much as you want in terms of usage, as long as the traffic, as long as the infrastructure that you set up is good enough. So there's two ways to pay for these LLMs. One is pay by token, and one is essentially host your own model. And when you're trying to evaluate the cost of your LLM application, just imagine that you're hosting your own model and you're doing some experimentation in the phase of POC, and you have a fixed bill for how much you think it's going to cost you, but then you have to scale up the infrastructure. It turns out that LLMs require very expensive infrastructure. They're using GPUs, which are hardware that is manufactured by companies like AMD and NVIDIA, also by Google. And this is by far more expensive than traditional hardware like CPUs. So when you end up using this kind of hardware to host your own LLMs, if you scale up, you do scale linearly, but the cost is way more than what you would pay if you scale up a computer with a CPU or virtual machine with a CPU. So cost of hosting can go dramatically up. Also, what we're also seeing is that sometimes you're not estimating how many tokens you're going to get. So even if you chose the pay by token model, you're going to OpenAI, maybe you didn't estimate correctly how much you're going to pay because the customers are going to send in more data, or you'll need more tokens in order to refine your models. So we do see customers failing in understanding the cost when they're starting off in the POC phase, moving towards MVP in production.
Is it as straightforward as like, okay, POC always use pay by token or always host yourself, or is there some sort of break even point? Are there specific use cases where one works best for the other? Is it a matter of taste? What are like the rules of thumb for selecting, if you're building an LLM based feature into your app, Are there any rules of thumb to consider as far as like how should you pay for it? Should you pay for should you use tokens in dev and staging, and then self-hosted in prod? Anything you can share on that?
There's a few rules of thumb, but I would say essentially at the very first approach, if you're even thinking if the use case is doable by LLMs at all, then of course the first thing you should do is go to ChatGPT or to Google or to Anthropic and just see if it's even feasible. You shouldn't start with the small model and then scale your way up to just conclude that it's impossible. But I do think there isn't a rule of thumb outside of that, because if you say you're always going to start with ChatGPT, then even though you can't afford it in production, so what's the point, right? Like, you just concluded that it's possible. So it depends on what you're doing. So if you have privacy concerns, essentially, you're never going to be able to use ChatGPT. If your budget is not big enough to use ChatGPT or a big large language model, then you shouldn't start with it unless you can afford it, right? So that's kind of, I wouldn't say there's a rule of thumb, but you should probably start with a big model and scale your way down instead of up.
I think I would say in this point that um, models are better as they get bigger. And that's like the rule of thumb. Like if you have bigger models like GPT-4, which is substantially bigger than GPT 3.5 or GPT-3, then these models tend to get smarter. So if you want to get accurate results, you're going to use bigger models. That, of course, means you either pay more per token or you need substantially heavier infrastructure to host your models. And then one other consideration is, are you allowed or do you want to send your data out of your premises? So it's really nice to share your data with OpenAI, but sometimes you just cannot because there is some kind of regulation that prevents you from sharing your data outside. So that would be also a consideration versus regarding hosting versus using an external service. And of course, infrastructure, because if you need to invest time in setting up this infrastructure, and that's very close to the discussion about managed services in cloud. If you need to set up your own machines and to install drivers and take care of the of hosting your LLMs on these machines, then you're spending a lot of precious time, which will impact your time to market, and that sometimes is even more crucial than your cloud bill. So all of these come together when you're trying to think of your preferred way of paying for the LLMs. It's time to market, it's privacy, and the quality that you get from these LLMs.
Yeah, I remember. I'm starting to remember this diagram, this triangle that you talked about as far as these three considerations. So it makes sense there. I guess with more and more companies using LLMs or introducing LLMs, I'm wondering, like, people before LLMs, people were talking about ML, and I'm wondering how like the makeup of a cloud bill has changed, maybe from 5 years ago to what it is now for companies that are now using LLMs versus maybe they were doing some ML ops stuff before.
I feel like a lot of the cloud bill has been kind of eaten by the LLM in your application. So it does feel like people are paying a lot more, but it kind of eliminated other costs because LLMs can accept so much more information. So I feel like it's kind of a shift instead of a growing, exponential growth.
I think what I can maybe add to that is, so in traditional machine learning, there was this amazing visualization from Google article from 2015 saying what are the hidden technical debt of machine learning systems. And the machine learning code was like the smallest part of the diagram. And then once you move to production, you have to take into consideration monitoring and processing of data and data cleaning. Now, a lot of this is actually being handled by LLMs these days. So if you're now using an LLM and you want to do some kind of classification, probably you need to invest substantially less in cleaning your data or doing feature extraction, because you don't do feature extraction for LLMs. They do it for you. You're doing it as part of the prompt. But what you do find is that it doesn't come for free. You will need to pay for it in the manner of paying for the LLM to do that. So you will pay for all of the things that you gave up on, like cleaning your data or feature extraction, or time designing the perfect classifier for sentiment analysis.
You talked about GPUs. Is this something that you only do you still need to think about GPUs if you're doing pay per token, or is that only something you think of, like, as far as like the choice of hardware? Is that something you only need to think about if you're self-hosting or self-hosting your LLM, or is that something that you think about regardless?
So one way to think of it, of the way that cloud cost changes, if you look at Amazon, for example, they went into this competition a little bit after Google and Azure, and they realized they don't have a good LLM offering of their own. So they partner with companies like AI21 and Anthropic, and they started to offer these services also in a pay-by-token model. So you see the cloud vendors themselves are adopting the pay-by-token approach. And the reason is because the costs are so high, you want to have good association between the single request and the cost to it. So just putting an LLM and paying it for for whatever data you're going to send is going to make it really hard to later on understand what was the cost per customer or per session or per a specific part of the application that is responsible for performing some kind of a task. So paying by token gives you much finer granularity in understanding what is the cost of running your application. And I think with generally hosted LLMs, it's a bit more difficult to associate that, even though you can always measure the amount of data that is sent by each session and then try to attribute that.
I think it's also important to understand the scalability of self-hosted versus those APIs, those token-based models. If you host your model yourself on Google Cloud, for example, you want to host the Llama model, the biggest version with 70 billion parameters, you pay approximately, $5,000 per month, and it runs on 8 GPUs. This is just one instance, right? And if you put this into production and you get a number of requests, you might need another second instance of that. So you need 16 GPUs just to host 2 versions of this model. Compared to the API approach, where you only have your quota limits, maybe it's 700, 800 requests per minute, it's much easier for you to scale and manage the costs because Google takes care of this scaling at a much larger scale and not you by taking those 18 GPUs or 16 GPUs and pay it yourself. I mean, that's also an important factor. How scalable are those solutions? We all know GPUs are hard to get. If you want to get another 8 GPUs just to have a second instance, yeah, good luck with that, right?
Does that introduce the same sort of cloud problem that we have with a lot of other services? Thinking of serverless function as a function as a service type things, where if you suddenly have a huge amount of extra traffic, you could be up for an enormous bill from Google. So when you're hosting it yourself, yeah, it might be hard to get 8 more GPUs or something along those lines, but at least you know that when the service is exhausted, you're not up for more cost. Okay, it's going to be a bad experience for anyone trying to use it. But if it's unlimited scalability from Google, is there some way to put the brakes on that so that you don't end up spending $5 million a month instead of 5,000?
Yeah, I think you can regulate this quite easy with the quotas. If you have the limit of 400 requests per minute, you can calculate approximately how large the bill gets depending on the number of tokens, but you are limited. So it will not scale unlimited. It's always based on the number of quotas.
Okay. I always like to have guardrails in place.
God, you were talking about size of models earlier. How do I know kind of what's the right size and type of LLM for my need? Like, how is size even determined? Like, I'm not even familiar with that, but like, what are the parameters or factors for size of an L? Like, yeah, I guess what is the measurement here, and how do I decide on what's right for me?
So size matters quite a lot in LLMs. So essentially, we hear a lot about the number of parameters. So this is the main measure that we're using. But 70 billion parameters in a model might mean there can be a trillion parameter model that is not as smart as a 70 billion one. but overall is quite a good measure of the capabilities or the generic capabilities of a system.
What's the smallest model that you would call, like how many parameters does a small model have, which is still an LLM?
So usually like 7 billion is kind of the benchmark for a small LLM. But these days there's very interesting research on going smaller. So I've seen I think it's called Tiny LLM, and it's a 1 billion parameter model, which obtains quite good results in specific use cases. And I think we're kind of going back in a way to, like, we went from BERT, what? A big model. So a big model that you would host yourself would be 70 to 180, 90 billion parameters. GPT-4 is claimed to have, I think, around a trillion. However, there's a lot of smart people making it run faster than it should on a trillion parameters.
So I'm going to try to get past the idea of putting a size like a small large language model or a tiny large language model. I mean, it sort of seems a little bit difficult to me. But just for those that don't really know much about this space, what is a parameter in this space? Is it a page of text? Is it like a parameter like when programming? It's an on or off value. It's how does that break down?
So usually it would be a float. So the default is usually a 16-bit float. So it's just a decimal number, or in this case, not a decimal, but a float. So essentially, the precision also varies in a lot of these models. But you start with the max precision, and then there have been a few innovations that look towards reducing this precision, or even developing new data types just for machine learning, which is what most GPU vendors are starting to use right now. So this is what's called bfloat. So there's a lot of different ways to measure size. So you could say a billion parameters, but if the parameters are 1 bit, then it's a model really big. But if it's a billion parameters with 16-bit precision, then the model's still huge.
I mean, following on from that explanation of what the parameters are, how does that translate into the amount of storage that we need? So say we've got an average size starting at 10 billion parameters or 7 billion parameters, something like that. How much are we actually needing to store?
Maybe the right word is, so we're saying that LLMs are basically some kind of like a data structures of floats in the memory. And what's interesting is the more the rapid access memory, specifically of the GPU. So it's important to say that if you really want to get high performance, you're not going to store it on your disk. You're not going to store it in your computer's RAM or virtual machine's RAM. You're actually going to use the memory of that GPU. And maybe Gabriel can address to like how much RAM do you need in order to host a small LLM versus a big LLM?
Yeah, so smaller LLMs can fit into consumer hardware very easily. And there's also the aspect of VRAM in GPUs tends to be, you can use multiple GPUs to run a single model, which is quite useful. Otherwise, things would get pretty crazy. But now that you mention it, so even though I said that it can run on a laptop, people still kind of struggle to run those bigger local models themselves. So there's kind of an advent of a field of people hacking together consumer hardware to run LLMs, because it's a lot cheaper than actual AI research grade GPUs. So there's a lot of optimizations these days to make it fit anywhere.
I'm reminded of the old days of people putting together PlayStation 4s to create big clusters for compute. Can we do something like that? Can we get all our Xboxes together and try and make something here?
Probably can't, but someone probably has already done it and runs an LLM on a fridge or something.
Are there also, besides sizes of models, are there, I guess, I heard the word general models or generalized models before. Does that imply that there are specialized models as well?
When I said general intelligence models, this usually applies to bigger models. So, for example, ChatGPT will be able to perform tasks that it saw somewhere, or even that it never saw, because it's so big and it has so many connections that it's able to it has a brain almost. But smaller models outside of their specific use cases, specifically the 7 billion parameter models, tend to be completely useless and they start hallucinating. But if at their best, they're as good as the big ones. So that's why there's a distinction. It's not that they only do one thing, is that big models could do anything with very little investment.
I think there is the term foundation models. So when you're talking about machine learning models or LLMs, you would typically hear about foundation models, which are the like vanilla version. They have high precision, they're quite big, and they're generalized to perform all the kind of tasks that you would expect of an LLM. You know, as the bigger they get, of course, they get better at doing what they were supposed to do. And there is even a wonderful piece from Google when they released Palm showing that the bigger the models get, it's not just they're smarter, but you're adding capabilities. So if smaller models can do translation, bigger models can do reading comprehension. So they're learning new capabilities and they're learning to do it better. But then again, like the model gets big, it's going to cost you more. Either you're going to pay by token or you're going to host your own model. You're going to pay for more GPUs. You're going to pay more per token. So how can you reduce the cost if you don't want a general model that can basically answer any kind of question? Can you take a smaller model and fine tune it to be more specialized at a specific task? And this is a very viable solution that we are seeing with customers. So they start off, and I think this goes back to an earlier question of yours. They start off the exploration phase with an all-capable model like a GPT-4 because they don't want to spend time fine-tuning the system from the first place. But then they realize when you're building an LLM application, you're actually making a lot of calls to different LLMs for different reasons, right? Some of it could be guardrails, some of it can be generation, some of it can be information retrieval. So you're using LLMs for different reasons of your application, for different purposes of your application, and then you can fine-tune your whole system by choosing the right model for the right task. So if I just have an LLM that is supposed to convert formats, I really don't have to use GPT-4. To take some data and format it as a JSON, I can definitely do that with a much smaller LLM.
So then, in the situation where I'm using multiple, I need multiple capabilities from my LLM system. Am I better hosting many smaller ones or one bigger one that can do everything? Is it better to go more specific or more general?
I'd say if your company's use case is specific, then go specific by all means. But there's also research that have kind of a layer in between that's basically as a router to specialist models. That's also a very interesting approach. So if you're doing math and translation, maybe it's better to detect what the user asks for, either one, and then just route it. But I think you should go as small and as specific as your use case allows you, pretty much.
Now, and back to more of a cost focus or cost related question. Initially, we were talking about model sizes, and I think we were talking about model right sizing in that context. I thought that quantization and right sizing in this were the same thing, but I guess they're not. I think of quantization as like maybe zipping a file, like when we used to use WinZip and stuff. But maybe you could explain it more and how it impacts how quantization impacts the costs here when you're using LLMs.
Yeah, so quantization is huge these days, and it's pretty much, I would risk saying, unless OpenAI comes with some secret research, probably the biggest area of research right now and for the near future, because it's essentially compression, like you said. But I wouldn't say it's like zip compression, it's more like JPEG compression, where if you compress something that has very high quality, you can really barely tell. And the savings are huge because an uncompressed image takes gigabytes sometimes, and you can get it to like 10 megabytes, and most people wouldn't be able to tell. And the same exact thing happens with LLMs, where if you do it right, you don't go too far, then you're probably not going to be able to tell, and the savings are proportional to your compression. So a very common thing to do is to compress a model between 16-bit float to 4-bit integers. And the savings are proportional. So it's a quarter of the VRAM, a quarter of the VRAM for training, for inference, for everything.
So should I always, is the verb quantize? I should quantize my LLMs. Is there like a time where I don't want to do that? What are the repercussions, if there are any, like negative, that maybe the people listening should be aware of?
So essentially, there's some research that says that quantizing LLMs tends to kind of dilute a bit of the fine tunings that were made before. But there's also ways to now kind of fine tune these models while you quantize them, which is even cooler. So it kind of does both. So if you have the time to do it, then yes, by all means, make a model bigger and then quantize it. So it's much bigger to have a 4 times the number of parameters model quantized to a quarter of the size than to have so instead of 7 billion, you could get like a 40 billion model, then quantize it to have the same size as a 7 billion. And I would say like 100% of the cases, you're going to get better results.
I would take it, Matan, the question back to the idea of what are we even building applications? So let's say I'm building an application. Let's get it practical. I want to develop a chatbot that is going to do some customer support. And using LLMs, I can successfully answer a customer call within the same accuracy of a human being. But that would cost me, with the top-notch models, it would cost me $20 to do. Is it more expensive, or is it more affordable than having a person do that? And then you realize that $20 per call maybe is more expensive than what you would pay a human being, and you would rather remain with your human support. But then you're asking yourself, of that $20, how much needs to be done at the highest precision with the biggest models versus how much of it should be done with quantized models or with smaller LLMs? And you have multiple dimensions that you can play with in order to reduce the cost. Quantization for itself costs money. Quantization maybe sometimes requires that you fine-tune your models for a specific task, so it doesn't come without any cost. If you have to choose between a quantized model that is pre-made, you can download these quantized models, go for it, yeah, for sure. But if you do need to invest, you do need to think of where is the right investment to quantize my models.
When you say fine tuning, is that like, I don't like the answer that my LLM or my app spit out. Let me tweak with the prompt I give it behind the scenes, and to make it give more accurate or more desirable answers. Is that what you mean by fine tuning? Yeah. I was reading it about sarcasm, generating sarcastic responses, right?
Yeah, exactly. Fine tuning is where you again go a little bit step backwards, like this more traditional machine learning, where you again need the data set. You need to have data to fine tune on. So before you can fine tune, you first need to collect data. Like you said, this is a good output. This is a bad output, and usually you can also, during those, when you deploy your model, your not fine-tuned model, you can collect the feedback from the users. Right, this was a good answer. This was a bad answer. And later on, you could use this data to, again, fine-tune based on your model and use some of the fine-tuning benefits you get. It's not only fine-tuning and quantization. It's not only about the cost. It's also about the inference speed. If you quantize your model, you also can get a much higher inference speed. So you can speed up the prediction of your models as well. But it's not prompt engineering. What you referred to is prompt engineering, where you can optimize the prompt to get a better output. Fine-tuning is actually taking data and training again based on this data.
I'm guessing also fine-tuning itself costs money. So there are some things to consider or think about when you're fine-tuning. It too much, how you're doing it, right?
Exactly. You need to have a good data set again. So you cannot just take data. You need to make sure the data set is good, which, yeah, what I said, it brings us back to this more traditional machine learning again.
I remember I saw this meme, I think, God, that you shared it, and maybe it's in your presentation too, about how costs can quickly escalate when you're using LLMs. I think it was with Vince McMahon.
Exactly. I think you asked me in the beginning about that company that we worked with that developed a solution, and one thing that you can get these days with LLM is a lot of marketing and attention. So if you release a feature that is based on generative AI, that has value of itself, even if the unit economics of it doesn't work. So they didn't care too much about measuring the unit economics of what they were building, and they released it. And luckily, they did put in monitors on the cost. And as more and more customers wanted to use it, they hit the limit to the extent that they couldn't onboard more customers, and their waiting list continued to increase. And now they're like looking at the system and it's like, what are we gonna do now? Because there's a bunch of people who read about the that feature, and then like the marketing is wonderful, but it's not sustainable to keep onboarding more people. So don't get a bill shock, don't get surprised. Try to understand where your application can go. You're never gonna be able to fully nail it in advance. It's like everything. Like you're gonna get surprised when your application meets production and meets people and meets real users. But at least try to understand where the cost can come from, and that could come from not using caching. That could come from doing embedding too frequently. That could come from increasing your prompt size. That could come from users sending in more data as part of their request. So all of these can accumulate to costs that you did not expect.
In this case, that company, was it that they didn't anticipate the amount of interest for this feature, or was it that they didn't anticipate how exponentially costs would grow or compound once they introduced it, once they went from POC to production, or both?
So maybe like generalize, because it is something that we see more than just one company running into. They're building the POC. All they care about is to just make sure that it works, right? You're building some kind of a demo. Maybe you're doing it to just show it to some stakeholders. Maybe you want to get feedback from your users, and you just want to get it work. And then I think then you can like maybe distinguish between two companies. And we need to be honest about it. Not every company that develops applications these days think about what's the unit economics of my application. How many of the companies that you work with are familiar with how much it costs, like a user session cost, and can actually attribute the cloud cost per customer or per user or per session? That's not common, but with LLMs, it's a new thing. It's becoming much, much more serious issue. So one thing is that they're not even doing the unit economics. And the other thing, even if they saw the unit economics is not that profitable, they say, never mind, like we can still burn some more money, and we'll fine tune it we'll fine tune our system further down the line. But then the pace in which people are adopting AI sometimes is much faster than what they can actually catch up to after releasing the product. And I think you did see, this customer is not OpenAI, I cannot speak on their behalf, but OpenAI, for example, stopped for a second onboarding new users to GPT Plus. So ChatGPT Plus did not accept, I don't know if they released it already, but there was a point that they said we cannot onboard any more customers to ChatGPT Plus. So if you think that customers are merely like, idiots that don't know anything about AI, they haven't figured out, like OpenAI themselves got to the point that they like had to slow down adoption because they couldn't build the infrastructure in a way that's scalable and profitable for them.
I'm curious, Sasha, are any customers asking these questions about unit economics that you're dealing with? Are they still in the POC stages of building features? Are they in production already? What have you seen from the customers you've worked with?
This depends on the customer. Some customers are very budget sensitive, and they want to know exactly how much this will cost when it goes to production. And they're planning and they're trying to get some estimations. That's the only thing you can do. You can try to get some estimations. How large is your prompt? How large will be your potential output? And how many users you have per day? How many requests you get? And then you have your token price. You can do some calculations. And that's the easiest way out. As Scott said, you have a lot of surprises. You have maybe more users because you now rolled out this new AI feature. Everyone is using it. Costs are exploding. This is the first side of things, so the cost-sensitive customers, where you do your best to get some idea around the costs. But sometimes you also have the customers, they just want to use the latest shit. They want to use the largest model. And those customers, you usually need to slow down a bit. Does it really make sense to use now the latest, biggest version of a specific model? What is your use case? What are you trying to build? Maybe a smaller version of the model will also do the best job. So you need to make sure it's right sizing. You need to make sure you use the right model and keep the budget in a more manageable way.
So coming back again to what Gard said about using a NASA rocket to get to the shop and buy some milk, right?
Exactly. Yeah, we tend to like to use those newest, largest models because they are much more better than the previous version. But yeah, do you really need it? Probably not.
I'm not going to lie. If you offered me a NASA rocket to go to the shops, I'd be using it, right?
Because it's a lot of fun.
It
yes.
feels like we're kind of like in that stage. If I'm comparing to like iPhone, it feels like we're at that whatever the first iPhone was, where they allowed you to record videos without you needing some jailbroken app. So all I'm saying is that it feels like we're early in this. So what does the future look like in terms of, you know, things that could influence the cost dynamics of LLM applications?
In this regard, I would actually want to speak about something that we're doing in terms of like trying to help our customers going further with LLMs to production. So we identified it quite early, and that customers are going to have serious issues with cost, and therefore we started to collect this knowledge and contribute it into our open source called LLM Studio. You can find it on llmstudio.ai. And what we did find is that a traditional method works, right? Basically, when you're trying to optimize for cost, what you need to do is have visibility, have logging, monitor, think. Don't like throw all your problems on the LLM. Make sure you understand what you're paying for. So what I would say is that we think in the near future, more and more people are going to go back to traditional methods of understanding their cost, trying to have cost visibility on the request level, leveraging tools like LLM Studio in order to tag each and every request to an LLM, and try to better understand and group by and use tools like BigQuery and Athena and QuickSight and like all the traditional stuff that you would use in order to understand the cost of your cloud application.
You talk about tagging requests, and so you know which LLM kind of is responsible for what request. Is this kind of like a similar issue in terms of allocating costs and understanding where they're coming from, like as we see with Kubernetes, or is this more complicated? Am I completely way off?
It's the same domain in terms of problems. Sometimes you have a mix of workloads using the same resources and you cannot separate them. In LLMs, we still see a very high granularity that you can get to, although in managed services, sometimes it's more difficult. But yeah, you would use tags on machines and tags on perhaps some kind of workloads, and you want to understand these tags that you later on collected, and you know what was the price of them, or what or the amount of resources that you used, how are they associated with the business value and with your revenues and with your profits or losses in some cases.
You see, Matana didn't even need to bring up FinOps. Gard's led me straight into it. But I mean, this comes back to the same old talking points that we often have, and that is that the cloud billing data that you get, or your own cost data from your own wherever you're running things, is only going to have your details about your hardware. It's not going to have down to individual requests necessarily, and it might have you can find out how many requests you ran, but not how many per customer or end user or whatever that is. And that's where the instrumentation of your own code comes into it, saying that this was for my front end, this was for my user, this was for my recommendation engine, whatever that workload is, and which part of that workload. The same issue you have with Kubernetes and things like kubectl can solve that by getting into the context of what you're actually doing there to find out and get to real unit economics. It's a very, very big topic, and I'm sure we're going to be even harder with the plethora of different LLMs and use cases that people have out there.
I think there is like when we're talking about LLM application optimization, there is a huge elephant in the room that we're not mentioning, which is we kind of like touched upon it very briefly, which is, can you really replace your LLM with a cheaper LLM, with a smaller model? And how do you know how would you even measure and what do you even measure in order to get to that? Because let's say I'm downgrading from GPT-4 to GPT 3.5. What's the impact of that? And sometimes the impact is going to be in something that is really hard to measure, which is accuracy. And that comes in, here comes in like a dimension that typically you didn't have in traditional cloud FinOps, right? Beforehand, you could just say, if I downgrade to that machine, I'm going to pay by latency or availability of my machine. But this time, it's like my application is going to be less accurate in some domains. How do you even map the impact of going dumber to smaller LLMs? And with that, it's important to actually, going back to what Sam says, you need to log not just your cost and usage, but also the data. And what I recommend that you do right away is, for example, in LLM Studio, check out LLM Compare, which is a process that you can run in order to benchmark the actual results and see if for the same level of accuracy, let's say 99% accuracy, you could go and reduce the cost by 90% using 3.5, or are you going to not stand within the required accuracy and you have to stay with GPT-4, or maybe you need to move to Anthropic. So this is this is a dimension that you really have to look into. There is not just like how much you're paying and what's the latency, but it's also the quality of the results that you're getting. And that is really difficult to measure. And for that, you need to use specialized tools.
I was going to say that you made a really good analogy about the camera app in iOS, and kind of wanted to explore that because it does feel like I always wished I was a developer during the boom of apps in general, because everyone wanted an app. But if you think about it, the good apps didn't come when apps starting being a thing. They came after everyone knew where apps should be a thing and where they shouldn't. You don't need an app for your water bottle. You need an app to call an Uber, right? So, and I think the same thing happened with kind of machine learning in general. When deep learning started being a thing, a lot of companies made a machine learning department to just then use traditional machine learning approaches and never touch deep learning in their lives. There was even a discussion even a few years ago that deep learning is never good for production unless you're doing research. And now with LLMs, I think the same thing is going to happen. There's a lot of hype. Half of the companies are going to give up in their applications. Better applications are going to come from it. And a lot of people are just going to start using NLP out of it. And in the case for FinOps, I think it's just a shadow of what it's going to be, because people are not too worried about making money right now, but they sure as hell will be. So establishing the pipelines for measuring your costs to defining profitability right now will make you Uber instead of the app for your water bottle that no one installed.
Is Uber profitable?
Well,
I was thinking about those. Yeah, you said it right with those really apps that came out in the beginning, like
and the lighter app,
where you could
like
sound like T-Pain by the lighter app. I did use the coin flip app to get out of getting a ticket from a police officer when I was in high school. So those early apps help. That's a story for outside the podcast.
But I think, I mean, it's a good point that Gabriel makes, bringing it back to the topic for a minute, where a lot of the apps that you see now that are useful, and a lot of, I mean, with every game-changing innovation that we see, the stuff that comes at the start is always, people starting to figure out, what can this be used for? How can I start using this technology? And then, to borrow the phrase, standing on the shoulders of a giant, we build and we build and we build, and suddenly 10 years later, 15 years later, with at least the iPhones, you've really got useful apps, powerful apps that are doing a lot of things. I think the Gen AI topics are going to go a lot faster than that, but it does match the discussions that I have with some of my customers, where they really want to get into Gen AI, but they don't know what they want to do with it other than be one of the cool kids. And exactly as Gabriel said, NLP covers an awful lot of what they want to do. Things like sentiment analysis, things like trying to summarize a document. You don't always need, if you're only taking the key points out, not getting a really detailed summary, you don't always need a 1.75 trillion parameter model to be trained. just to get the basics out of what's written in my Google document, right?
Yeah, this brings me to the point what I usually recommend when our customers get started building large language applications. Take the smallest, cheapest available large language API, which is based on tokens. Try to build your solution there. And only if it doesn't work with the smallest cheap models, which you not host yourself, you can scale up. You need a larger model. Maybe you need to refine your idea, your business use case, but always start with the cheapest one. You're not taking the latest advancement in LLMs.
It does feel like ChatGPT in general was mostly a sales tool for NLP solutions, because you can just type your use case and suddenly you have this, like you're seeing it, it's possible. There is out there an NLP application that can measure the sentiment of my book or whatever, right? And then you can just scale down, or you can convince the customers to scale down and that they don't need ChatGPT. But the thing is, that's a use case that would have never happened if ChatGPT didn't exist. So I feel like this is a very exciting time to be a machine learning practitioner.
I'm seeing the emergence of lots of like specific GPTs out there. Like I saw one that recommends nonfiction books to you based off of, whatever your input is. Are those example? I don't know if those can be monetized, if those are being monetized or what. I'm seeing actually on Notion, I think I paid for like $20. Someone made a product launch friend or helper using, I guess, prompts that they entered. You pay a one-time fee and you just input the name of the feature, what it does, and it's supposed to spit out like a product announcement and stuff like that. Not that I've used it, but I was experimenting with it. And so I guess, would that be an example of like a specialized model, or is that using a generalized model to do specialized things? This is kind of at the end. I was just wondering, because I was looking at these more specific GPTs and wondering, like, is this kind of, are these examples of apps in the beginning of the iPhone, or is this kind of like, what do you make of these?
I think we're in the gold rush of LLMs for sure, and AI. And some people are gonna find gold, and some people are gonna not find gold, and some people are gonna just sell shovels. So you can ask me where TensorOps stands on LLM applications. I didn't say I'm going to answer.
What is TensorOps then?
I'll go over to Portugal and then I'll get the answer. I think that wraps things up for us, unless there's any final comments. So this was quite the doozy, as we say in Israel, which we don't say. But yeah, hot topic. I'm sure we're going to be exploring more niche topics within LLMs with you guys in the future. And considering we work together in several ways. So thanks for joining us, Sasha, you as well. And for those who are still listening up into this point, for all two of you, I will share a bunch of resources, including LLM Studio. Sasha's written tons of great articles on GenAI. He also has some videos. So the episode notes will be filled to the brim with useful resources you can take a look at to experiment and learn more. Thanks, everyone.
Cloud Masters is a DoiT multimedia production, hosted by Matan Bordo, a product marketing manager at DoiT, and Sam Clark, a technical account manager at DoiT. Our guests this week are Gad Benram, CTO and founder of TensorOps, and Gabriel Gonzalez, AI solutions architect at TensorOps. We were also joined by Sasha Heyer, a senior machine learning engineer at DoiT. To listen to more episodes of Cloud Masters and learn more about how DoiT delivers the true promise of the cloud, visit doit.com.